We continue our focus on climate patterns and study how latitude and altitude affect the climate of a region. Now, we know it's cold at the poles and warmer down near the equator, and you can even see this in the unit roadmap. We're going to look at that effect using data with a graph like this. Here's a snapshot of temperatures from cities around the world on a day in March. You'll be looking at a graph like this in the first lesson. Whenever I have a graph, I like to start by labeling the axes with words that really describe what the high and low values mean. The x-axis here is latitude, and negative numbers are towards the South Pole, and positive numbers are up here towards the North Pole, with the equator being right in the middle. Now, on the temperature axis, low temperatures mean cold, and high temperatures mean hot. There are points all over the place here, so I like to kind of draw what I see, an eyeball average, if you will. That allows me to ask, do I see any trends, systematic increases or decreases, or patterns where there are recurring changes? Your students will be creating a graph like this with temperatures of their adopted cities, but you'll have much less data. When we apply the same approach to analyzing this graph, we kind of see a simple trend. So is this trend wrong? Well, the essence of analyzing data is that we analyze the data we have. If we conclude that the temperature decreases linearly as you go further and further away from the equator, that's reasonable, and I want my students to make that conclusion with this graph, even if I know that's not the complete scientific story. But that's because there's also another part of science, and that's that we characterize our confidence or uncertainty with our conclusion. We can see here that there's at least a 30-degree Fahrenheit range between two cities that have kind of similar latitudes. So a line like this would fit equally well, or maybe a line isn't even the best shape at all. When your students learn more sophisticated math in college, they'll learn that scientists come up with the best fit line and also a formal estimate of the range of possible lines that could fit within the uncertainty of the data. But for right now, let's at least get them to ask, what do I see and what other trends are reasonable or possible for this data set? To tell which one is actually true, we need more data, which is the battle cry of scientists everywhere. And if you can get your students starting to chant it too, then you know you've taught them authentic data analysis. Let's look at the lessons where students do all of this. In Lesson 3.20, students will work on figuring out what factors affect the local climates of their adopted cities, including exploring latitude and altitude. In small groups, students are going to actually create two graphs, the altitude of each city versus average temperature, and the latitude of each city versus average temperature. And students then share what they've learned from this analysis, as well as any patterns that they observed. Then we put it all together with the latitude and altitude influence on climate presentation. In Lesson 3.21, we start class with a short presentation where students answer the question, how do mountains affect climate? They look at examples of different mountain cities and recognize the pattern that different sides of the mountain have different amounts of vegetation, because mountains influence where rain falls. We then have a short quiz to see if students can apply their understanding of the range of factors that influence climate to an example scenario. Up next, let's look at the role oceans play in climate.